Here goes the last little piece of the whole wiring diagram series. What I'm going to take you out here, I'm going to walk you through the connections real quick, but I hope what you've picked up from this is a little more than just putting the wires where they're supposed to go. That's all fine, that's all good, but what are you going to do when it doesn't work? That's the troubleshooting part, and that's the reason I try to put this out in terms of circuits and flow and things of that nature. So follow me out in the shop. We're going to look at an air handler real quick, and I'm going to show you the last two things to maybe start this in your head right. One's going to be voltage related and one's going to be amperage related, and then I'm done. So here I've got an air handler behind me, and what I'm going to do, if you remember the two diagrams that I started out with, I've got the printed copy of those in my hand. And I've wired this air handler with electric heat a couple times before. It's got a PSC motor in it. It's got the Goodman blower board in it. Nothing fancy. So I'm gonna walk through wiring it up connection for connection. And if you've got the old handout, the diagram, whatever, I'll throw one up on the screen just as a flashback, I guess. But it's not hard to do connection for connection. So I'm gonna walk through it. We'll do it kind of real time. Just takes a minute. So for me, I start with the female plug. I know it's the female plug. I know what corner's number 1 because they identify it with a little tab right there. So that means that black wire is pin 1. If you look back at the diagram that they give you with the manufacturer's literature and stuff, that's right. So the black wire is pin 1 and the red is pin 2. So I'm just going to connect this back to my L1 and L2. So that's going to be red and black, and I'm doing it my way because I know what I've changed in my head. Okay, this purple wire here, that's after the switch. So power, control, and then the load side with the heater is where that purple wire goes. All right, and the last two wires in this plug are going to be your 24 volt. I'm going to put the 24 hot on top, and since common is worth nothing, I'll put it underneath on the contactor coil, and that way if anybody ever did anything with it, it would not short or pop a fuse or anything. So that's your female plug. A lot of my guys that I have do wiring tests like this, they'll go ahead and plug the male and female together, and then it kind of blows their mind a little bit, so because they get the wrong end. Now we have the same wires on the other end, but with this one, whether it's low voltage or high voltage, you'll see it's got these little buddy clips. It's got the terminal with a space for another wire with a male extension or what. So red and black, that's going to go, according to the diagram, is going to go to our transformer primary side. So I'm going to put the black on the common, and this red, since I'm a 208 here in the shop, I'm going to put that on the 208 tap. This white would be where I would use a wire nut to connect to my field white wires. This purple wire that originated on the leaving side of the heat switch is going to go to the normally closed. That's going to be in well, that's your terminal 3 in the plug. And now I've got this 24 common wire right here. This is how the heat relay gets 24 volt common back to the transformer. So that's both my plugs. Okay, if I did the heat strips, I've got 3 high voltage wires here. Instead of 2 black wires for the heat strip, the high amperage part, you know, we're looking at like a 12 gauge wire here. I swapped up one of the black ones out for a red one just to kind of follow suit with them. So power L1, L2, control is the switch, load. This L1 side, which I've deemed red, is going to go to the heater. That's also where my purple wire is. This black wire here, so power, control to the safeties and the load, and then I return back. So this black wire here is going to go back to the other side of the heat contactor, we'll say, and that's return path, so that's there. One more high voltage wire. This is going to be off of the male plug where it hits the transformer on that L1. This is where I told you if you're following the flow from power to the blower motor, that connection right here, if you imagine it not even hooked up to the transformer. We're not trying to power the transformer with this wire. We're trying to get L1 into the blower relay. So that's the wire we're putting here off of the high voltage of the transformer into the normally closed for the blower relay. All right, with that being said, we'll finish with the blower relay. I'm going to put this one on high speed, which is the black wire here for this PSC motor. I'm going to put that into the relay, and with my other two unused speeds, they go on the M1, M2 of the blower board. I don't know why they chose M1, M2, maybe motor 1, motor 2, but those are dead terminals, go nowhere. So that's power, control, the blower motor would be the load, and then we have to return back. And there's a purple wire coming off of the capacitor on this diagram, and it goes back. It's a purple wire, but different purple than the heat relay purple. It goes back and jumps back onto the black wire at the return side of the primary of the transformer. So that's that wire right there. And the rest are low voltage. So I've got a low voltage here. I got 24 volts off of the transformer, and we're going to go into the transformer R of the board. Goes through the fuse. We've done the flow on that, and then it hits the regular R. And the regular R is where I just get a bare wire. I'm going to wire nut on the end, so I'm starting to build my low voltage connections. I've got a red and a white wire that would be my air handler wire nut connections. I've also got a transformer common. So this transformer common right here, in terms of flow, it would come from the board, and I have a little buddy clip on the 24 common of this transformer, and it's right there. So transformer common is done. Now we have a regular common, and that's my wire connection there, and I have a regular G. So to wire this thing up off of the wiring diagram is not that hard, and you wind up with a couple loose ends, and this will be your air handler connections and a wire nut and stuff to your field wiring, to your thermostat and your heat pump or air conditioner, whatever you have. So there's your connections. Here's what I would tell you. Let me back out. How long did that take? Oh, just a couple minutes. So here's how I use the diagram. All right, and I've made some little notes here. I'll take a picture of this, throw it up there. This is what I did as a young guy in the field to get my head wrapped around it, and real quick you kind of get the idea that it's either high voltage or low voltage, right? This really, now that you can see me, for me, what I'm about to show you really comes into play on maybe a larger commercial system where you have multiple voltages, and I'm not talking 24 and 240. I'm talking about a 460 and a 120 circuit, or a 460 and a 240, you know, where you have multiple high voltages and a low voltage. So matter of fact, you may even be working on a dryer nowadays, okay? The dryer has low voltage, but it's got a 240 circuit and it's got a 120 circuit. So you got two high voltages in there, but what's supposed to be what? So that's where I'm going with this. Just bear with me, all right? So as we're looking here, let me get this back down here. When I look at this and I have this piece of paper in front of me, what I'm gonna do is I'm gonna make numbers, and do this with a pencil if you're using the manufacturer's diagram. If you've got a printout, whatever, you know, whatever works for you. So I had red pen here, so that's what I got. But I would go on the diagram and I would number a couple places. So for me, L1, L2, I would label that 1 and 2. And if I'm troubleshooting whatever circuit, if I'm troubleshooting the blower motor, and that's what I've got my example here, I'm gonna choose number 3 to be a point in the L1 side, and it's gonna be right here for what I'm diagnosing, we'll say. but I will go through and I will number various points within one circuit. Now, by looking at the diagram, hopefully you get the mindset of what voltage is supposed to be there. So I'm gonna make a half a dozen little annotations, points to check in a circuit, and by the time, for this blower motor circuit, I've got 5 points that I've referenced down here. Number one is one side of power. That's my L1 side of power, or my L2 side of power, I should say. Everything else is gonna be an L1 check. So as I go down, and this is where the hopscotch plays in, I am writing out my hopscotch circuit, or my hopscotch checks to check in that circuit. And if I do just 3 or 4, power, control, load, return, right? Depending on how many different plugs you have or relays you have. But as you go through this, what you'll see is, hey, I've got 1 and 2 here. I'm gonna leave my lead on number 1, which is my other side of power. And then as I leave that here, I'm gonna go to my next point that I've written down. Oh, over at the transformer. Oh, well, I've got 208 or 240 in this case, whatever. Oh, power's still there. So the problem for my blowers not being able to run is I hadn't found it yet. Oh, well, then it jumps over on that red wire up to the relay. So I check in the relay. Or in this case, since it's insulated, I pull the wire off and I check the end of the wire, right? But my point to the voltage part of this is you are essentially giving yourself the hopscotch on the circuit that you're looking for. And when I find power going into the relay but not coming out of the relay, my number 5 is right here on this common terminal. If everything said 240 and then I get here and it's 0 because it's not coming out, I would move this wire. Don't check the wire leaving the relay. I would pull that wire off and check that relay. But when you have 240, 240, 240, and all of a sudden you have 0, there's your problem, right? You've just found it. So hopefully you can follow that example. Hit me up with a comment if you need to, but that's how I would use it on the voltage. Now we're gonna look at how I'm gonna use it using amperage checks. Bear with me on this one. My allergies just started kicking up and I have no idea why. So anyway, so I just finished up chronologically, I guess. This is the next video after learning to read diagrams and that little 3-part series. So, but I had somebody talking about, where to check amp draws and things like that. So I really think that it ties back into reading the diagram. So what I'm gonna do real quick for a minute is just walk through several different setups, different types of motors, different types of loads like a heat strip, and just kind of show you where I would check them. But it all stems from how to read a diagram and knowing what power system I'm on and those basic things. So first up, furnace. So on this unit, I've actually, it's a 120 volt furnace, split system setup. We've got an air condition attached to it. But something that's different about this one is it's a 2-speed inducer motor on the motor side of the plug. Now the plug going to it is just 120 volts. It's got an L1 and a neutral. And if I'm dealing with a 120 volt load, I always check the neutral, because in the case of a 2-speed motor, what if they were both wired to run, low stage and high stage in this furnace, or whatever the situation is? No matter which one I'm using, low or high, which is the red and the black wires, I'm always using the neutral. That is always the other side. So anytime I'm in a 120 volt situation, neutral's the way to go. So I would, got a brand new meter here, I would check the white wire. So we're pulling about a ½ amp, depending on where exactly you put it. Try to center it up in there. Yeah, 1 amp. So always on the neutral. In this same furnace, I actually have an X13 style motor. So X13 style motor, if you've done any homework on those, you know that they always have a constant high voltage power source. It's It's on at 24/7, 365 as long as the power to the whole unit's on. Even though it's not running actively, it still has high voltage power on it. So as we read the diagram to find out where the connection is, which is good, you would find that it actually gets its power from L1 and neutral all the time. And since it's 120 volts, I always check the neutral, and you can see here we're looking at about 3 amps for that X13 motor that's behind this cover. So even though you can't see it, I know it's working. I can feel airflow in the return and the supply side, but it's the neutral. Now on this furnace, I've got a 120 volt setup, split system style furnace that we've got a heat pump on actually. So this will be a dual fuel unit, but we're looking specifically at this blower motor. So with this blower motor, it's not an X13 style. I can look right here and I see the capacitor for it. So that means it's a PSC motor. And I know that capacitors are always on the start winding. Anytime I'm looking at a diagram and I see a capacitor, whatever winding of that motor is going to, whether it's a fan motor or a compressor, I know that that's going to be the start winding. And for me, that that means something. So, but nevertheless, it's still a 120 volt appliance, and I've got a neutral wire right here, 6.5 amps. So even though I've got a multiple speed PSC motor, high, medium, low, medium, high, medium, low, whatever, we don't know which one it is, or let's just pretend you didn't know which one it is. If I'm in heat mode, it should be on the heat speed on the furnace board. If I'm in cool mode, it should be on the cooling speed. But no matter what, I'm always using the neutral because that is the return part of that circuit back to the power source. And here's my neutral wire right here. And even if I clamp here, I'm pulling 6.7 amps. So that's a little bit more than what I just pulled for the blower motor. But that's because we've got things like the primary side of the transformer that's also in this system. So for what I got here, this is the train unit that went with the furnace that I was just looking at with the 2-stage or 2-speed inducer motor. And once we get into air conditioners with a lot more wiring, then we have to be careful. You have to watch. So of course I've got my L1, L2 coming in, and there's a red and a black wire. Typically, if you're on a Goodman, it might be yellow and black, or a Rudd, it might be orange and black, or something like that. But whatever it is, you're going to have L1, L2, and this is a 208 system that we're on. But when you come off the top side of the contactor, you start getting into a little bit more. And what I look for is the capacitor. So when I look at this capacitor, I see that right here is this red wire jumping across from the left side of my contactor to the capacitor. And I know that capacitors always go on the start winding. So this L1 jumps over here so we can juice up this capacitor and hit that start winding. But this is my L1. I know the run winding also comes off of this. All right, so for me, that makes this side. So I've got 2 PSC motors out here, and this is my outdoor fan, and it's pulling, yeah, 0.4, 0.5 amps. And then this black wire here is going to be my compressor. Oh, there we go. Somebody. So we had a loose connection here. So we just had a loose connection, and that red wire actually pulled off. So I lost the L1 to my run winding and also into the capacitor for the start windings. But what I was trying to tell you is this black wire right here would be my compressor, the return from the common terminal back to the power source. Now, if it's a tight connection, I still know that it's on this side. So what I can do is I can come on the bottom side of the contactor where I have more room, and I can say, oh look, I got 5.3 amps. Just understand that anything on the load, anything on the load side of the contactor is basically individual components, but on the line side where the power source connects, that's going to be a, you know, a cumulative kind of deal. So I've got 5.44 amps, but that's both the compressor and the outdoor fan. So by me being able to clamp on the common side or the L2 side of the outdoor fan motor, I know that that's about a 1/2 amp. So of that 5.5 amps, 5 is going to be the compressor and a 1/2 of it's going to be the outdoor fan. And that's pretty much the only 2 loads we have out here. Then we get the good old heat pumps, and it's the same concept. So more wires, more wires, more wires. And you can look down here and you can see the oranges and the reds and everything. And once again, for me, I look for this capacitor and I see this orange wire that goes from the right side of the contactor up and into the capacitor. So I think that this is my L1 side, and it's on the right side of the contactor. So what I can do is, to get my amps on the outdoor fan, that's this black wire right here. And whoever did this made a mess. They got wires twisted off. We'll fix that later. But, well, that's actually the compressor, not the outdoor fan. So I've got 5.25 amps on that compressor. And here is the, right here on the defrost board, that's going to be my outdoor fan, and it's pulling 0.58, 0.59. So if I did the bottom, the line side of the contactor, I would get 6 point something amps, right at 5.8. So hopefully that makes a little bit of sense, is to look for something obvious. Now, like I said, we could follow the wiring diagram and it would tell us, you know, probably the color wire and everything. You could follow that connection, but if I'm without it in the field, I look for the things like that wire going from the contactor to the capacitor. All right, so last setup for the day. Like I said, this is all residential based anyway. So what I've got here is my heater kit and a PSC motor in here. So because we were going to toss this air handler and replace it with a new one, we don't have a thermostat on it. I've just taken and wire nutted the red to the white so I can get the contactor to pull on. And because this is a PSC motor, you're going to have this redundant safety circuit, this purple wire that we already know backfeeds into the blower relay through the normally closed circuit to turn on the PSC motor. So for our purposes here, I'm just going to do red to white and everything's going to click in fine. So it's going to be noisy, the blower's going to come on. But some loads, it doesn't matter which side you check it on. So in the case of the heater, it doesn't matter. Once the heater comes on, I'll disconnect the blower. So I'm holding this high voltage one out. I'm gonna turn on the breaker and the heat strips are gonna turn on. There they go. So if I check the amps on this black wire, 18, 17, 9, there we go. And if I check it on the red wire, it's 17, 16, 9. So basically the same thing, but I can feel the heat coming off of this. So I'm gonna go ahead and plug this blower back on. Come on. Now, if I check off of this purple wire, 1.92 amps, but you have to remember this purple wire is not the other side of power. So in a PSC motor, we've got 2 windings and they're each gonna pull their own amperage. They're like 2 individual loads. So for me, I know that this purple wire over here, coming back to the black wire, which goes back to my L2 side, that is my other side of power. 1.9. Now for a PSC motor, because you've got 2 windings inside, and I'll show you one more setup where hopefully you'll see it better. But just because you check the amps on one wire, we know it's powering there. Sometimes because of those 2 windings and the relationship that they have and the resistances and the different amp readings, the amps you get on this wire may not be what would be the total motor. By checking on the common side or the return side of the circuit, I let the electricity figure itself out first. So I know this purple wire is powering, so it's got 1.9, and if I come over here, I know that purple is going to my high speed, which is powering the motor, and it's going to be the same, 1.9. 1.97, yeah. But I do know that as it goes down to, because this is a 3-speed PSC motor, it does whatever it does on the run winding and the start winding, and then it comes back on this wire. It may not always be the same, but in our case it's 1.86, 1.98 if I hold it kind of centered. So it's almost verbatim the same. All right, last one. Just so you get in my head a little bit here. So here I've got a PSC motor. I've got the capacitor over here in the unit to my left. And on this, you'll see 3 wires. Now this is a PSC motor. There's only 2 windings, not 3. You got to get into a 3-phase and some of your variable speed X13s before you get, more than those 2 windings. So, but there are 3 terminals: common, start, and run. Run and start, the R and the S, they go into their respective winding, and they both meet on one end, and that's the common terminal. And you probably have an overload in there, some type of temperature safety. But the common, this wire is not for a winding. It is strictly a one-way road back from these 2. All right. So watch this. We're gonna check the run. .3.1 amps. The other load in this motor is the start, so let's check it. 3.35. So what's your amp draw? 3.1, 3.35. Since it's 2 independent loads, do they add up? Watch what happens with electricity on the one way out, the common terminal, going back to the other side of power. 4.85. Now how does that happen? So this is, for me, this is the importance of knowing how to read that diagram and what side is my other side of power in the circuit, because electricity is funny and it will figure itself out, and all you need to do is know where to check it. So I hope this helps. If you have any questions, this is not the end-all be-all. There's a lot of different motors, a lot of different loads out there, but it works the same on high voltage, and low voltage is pretty easy. There's usually only 2 wires there, so pretty much it's not like a PSC motor. So if you have any thoughts, questions, just hit me up, let me know. Thank you. So I hope this little video helped, just to maybe help you build confidence in your diagnostic skills, maybe to help you get a starting point on how to develop those skills. I found it very useful when I was coming up in the field once I found this little technique. So yeah, there's no possible way for me to cover every motor out there, so I'll give you what I had. Shaded pole PSC motors, X13s that are becoming popular, with the variable speeds and such. So you can use this on high voltage and low voltage. It works either way. Just make sure you pay attention and know what power source you're dealing with, what voltage you're dealing with. And it should help you understand things a little better, and even recognize the sequence of operation a little better. So with that being said, I'll see you next time.